Good afternoon. My name is Jason Johnson, amateur radio operator with the call sign Kilo 3 Juliet Sierra Juliet. And today I'm going to present my second video in the series for Bowie Wireless Association on digital mobile radio. So my contact information is shown here on the slide. So in the first video, I provided a high-level background on some of the drivers for why DMR is used and why we should be interested in the topic. So for this video, I'm going to cover some of the what about DMR. So what is DMR exactly? What are some key similarities in that it has an analog, and what are some key differences, as well as some definitions which you'll hear quite a bit with DMR. So what exactly is DMR? Well, it's a international open standard for transmitting voice and data over radio networks. This was come up as a standard several decades ago, and in Europe it was actually developed, and a large RF company, Motorola, brought an implementation of this into the United States. The thing about an open standard is that anybody can take it and make it to be what they want. And underpinning DMR are a number of technologies that I'm not going to go over a lot today, but I'll just kind of mention these in passing. The first is that DMR uses digital modulation for transmitting information. So digital is different than analog. In analog, you have kind of a wave that has a continuous level of information that you transmit. With digital, on the other hand, you may have a limited number of bits of information. So you're actually not transmitting a waveform that kind of moves in a continuous way, but you're actually transmitting discrete values to send the information across the RF channel. With transmission and radio, we all have encountered situations where we send something, but at the receiver's location it wasn't properly, or maybe there was a garble along the way. And this is just due to how RF works. So to overcome this, there's a capability called an error correction code. And essentially you transmit your information that you want the receiver to receive, but you have a little bit more information that you include. So when the receiver receives the data information, they can use the error correction information to fix an error. This may be maybe a bit error that was flipped from a 0 to a 1 when it shouldn't have been. Also, certain error correction will kind of replace missing information, but I won't really go into how those particularly work. The third major area that digital mobile radio has is voice encoding and decoding. Another short term of this is called a codec. So with a codec, your voice is sampled by, say, a computer chip, or an algorithm, and instead of sending the discrete waveform where your audio is moving, it takes that information and encodes it into a shorter sequence of information. So why is this important? Well, one of the reasons it's important is you don't have to use as much bandwidth to transmit the information. Some of the first digital ways of transmitting voice, when this first came out, I think it was ISDN was a service, it was a 64 kilobit per second channel. So you needed that much bandwidth to kind of, now that was voice and data channel. But with these codecs, generally our audio fits within a 3 kilohertz channel if you're talking kind of just normal analog voice. But with DMR, you can actually reduce that dramatically using these codecs. And that's important because the less bits required to transmit the voice, the less bandwidth is required to send it over RF. Being the open standard, there's a number of different implementations that have occurred. So DMR is a standard. It's also other ways of thinking about this is Tetra, which is a different implementation of that. Moto Turbo is an implementation by Motorola, which is a US company. And then you also have NXDN, which is a different implementation. Not to be left out, amateur radio had developed a couple different ways to address this. And the first is Yaesu, which came up with Yaesu System Fusion, as well as ICOM's D-Star. So there's similar concepts between the digital amateur radio implementation, as well as these other ones. And they can interwork. You can make ways where you can kind of interwork between these different technologies. So when we communicate, I think all of us are kind of used to the notion that there's a channel between ourselves, for example, for myself, and a local repeater. So a repeater has a frequency that it will receive on from the handset, as well as once it is received at the repeater's location, it'll rebroadcast that out to a wider variety of users. And there's a transmission RF an RX-TX pair at that repeater location. Also, a term that you'll often hear with repeaters is CT-CSS or PL tones. And what that's used for is essentially to tones may be required to get access to that transmit-receive pair. Well, I guess receive pair at the repeater. So my radio has to have this tone programmed into it in order for me, when I push my button to talk, that tone gets transmitted along with my voice, and the repeater receives it, and it will kind of rebroadcast that. On the recipient side, sometimes these tones are used to keep a user's audio muted. Like, for example, if I have my radio tuned into a local repeater, it will not unmute to my speaker unless a certain tone is received at my radio. So that's how repeaters work. I think many that are familiar with 2 meter 70 centimeter would kind of have that background. The important thing about an analog repeater is one person can talk at a time. So if I'm having a communication myself, and I'm going to call CQ, or I'm going to call, say, N3ADF, Jim Wallace, I would mention my call sign, I would call him, K3JSJ calling N3ADF. I would wait, say Jim heard it, he would reply N3ADF, this is N3ADF, K3JSJ, go ahead. And then I would talk. So under this construct, right, we can have a conversation taking turns through the repeater. Maybe Milford, a friend of mine, N3WYG, wants to have a conversation with another operator, Bill, N3XL, who's here in Bowie. Well, the challenge is, Jim and I are already on that repeater, on that frequency, and he has to wait until we're done with the conversation, or maybe a break in this conversation, and identify himself. So just keep that in mind, that with an analog you only have one user on that particular transmission or transmit and receive pair. So DMR also has a transmit-receive pair, which is kind of similar, but there's some new concepts with DMR called color codes. And there's also something called a talk group. So you can think of a color code and a talk group as being somewhat akin to a CT, CSS, or PL tone. It's something that you have to have set in your radio in order to get access to the repeater to transmit information to other users. The other part, which is different in DMR, which I covered in the first video, is there's this concept of a time slot. So a given transmit-receive pair has 2 time slots, time slot 1 and time slot 2. And what this allows there to be is the example I gave on analog. Maybe I'm having a conversation with N3ADF on time slot 1. Well, Milford could see that. He could listen to time slot 1 and see, well, Jason and Jim are talking. He could actually switch over, say, to time slot 2 and then have a conversation with Bill, N3XL. So that gives an improvement, and you have 2 users that can be kind of simultaneously talking on one transmit-receive pair. And the color code in the talk group, those are settings that control what you hear. And you can set those based upon what you want to listen to. And I'll go into what the talk group is and then a little bit more in the next couple of slides. So before I go into that, I want to talk about this notion of DMR has a concept of a zone. And what zones are is you can think of a way to kind of create a space for all of your channels that you want to communicate with. So in the picture that I'm showing now, this is for my particular setup. I have a couple different groups of channels that I want to bin my things in. The first one is PG Aries, for example. PG Aries is a local Aries group in Prince George's County, and there's a set of frequencies that are used to communicate with other members. These are analog repeaters and simplex, for example. And I want to be able, when I'm doing my operations, for example, to have my radio set to this particular PG Aries zone. And I can kind of be in that zone, and then I can move my radio dial and then move between the frequencies in that zone. The second example is I'll talk about is the October set. So the October simulated emergency test was a test that we did part of K3 BWA for the Maryland section, there was an exercise for ARRL. So we were going out in the field and finding these geodetic disks that mark locations. And we were using simplex frequencies. We were using simplex frequencies to communicate with team members, as well as a repeater to coordinate among teams that were driving around Bowie. And then finally, we were using APRS to do beacon reports of our location. So for the October set, I had a SET zone, and I had all of those frequencies programmed into that zone. And I could kind of, switch between them on our radio. So it was a very small, limited number, which was nice because I could kind of just focus on those channels, like those 6 channels, for example, during the event. And I don't have to worry about other channels programmed on my radio. I also have in my radio, I have a hotspot at my home. And I have certain frequencies and talk groups programmed in my hotspot that lets me talk with others. So any communications I have at home, I will take my radio and switch it to my hotspot zone. So those just pull up the frequencies that I'm using at my home location. I have another zone for local repeaters. So this is not only the digital repeater in the area in 3LHD, but several local analog repeaters because my radio supports both digital and analog. And then the final area I have in a talk group is for Bowie Wireless. Now this is a talk group I have for Bowie Wireless Association. This is a simplex frequency that we've agreed upon to talk with. There's a local analog repeater that we've agreed to use. And then also we're having conversations as a group about some UHF and VHF simplex frequencies that we can use for DMR. DMR, like analog, you can go point to point. You don't necessarily have to even go through a repeater. So I have four channels programmed in my radio for simplex DMR coverage. And then finally, I have an analog APRS frequency channel, as well as a digital channel to send APRS messages over the DMR network. And that occurs over my local hotspots, for example. So with a zone, you kind of saw on the previous slide that I have my own names for the zone. And these are names I picked to make them easy for me to operate and to kind of understand what's within there. The zone is used to group your channels. So things that belong together on a concept basis, for example, BWA channels, would be in the Bowie Wireless zone. You create your zone generally through programming software for your radio. So it's a program that you would install on your Windows laptop or desktop and program the channels and select which ones go in a zone. You can also use your radio's front panel to add new zones or to manage zones. And this varies based upon the radio that you may have. Some radios support front panel programming while others don't. I have the Anytone 878 and I'm able to create new zones and add channels to a zone right from my radio itself. One important thing that you have to understand, and this is, a lesson I had to learn through experience with working with a radio, is you have to have a channel in a zone in order for it to appear on your radio panel, your radio user interface. So you can program lots of different channels in, which would be the transmit frequency pairs, for example, time slot color codes, and talk groups. We'll go over that in a minute. But if you've added the channels into your software, but you haven't added them to a zone, when you go to your radio's menu to try to navigate to see what's in the zone, nothing will be there. So it's not that hard to kind of add channels to a zone. You would do that in the programming software. But just important thing to keep in mind, I did that a couple times when I first started using DMR, is I spent the time adding the channels and I wrote the channels in my radio, and I looked at my radio and they weren't there, and I thought, oh yeah, I forgot. I have to go back and add a channel to the zone. So we've covered a zone, and the next topic is a channel. So we talked briefly about this. A channel is just essentially a communications path that you'll use to establish a two-way connection. Now this two-way connection could be with a simplex frequency, for example, from your DMR radio, which I have mine right here. Right, I have my DMR radio here. To the hotspot in the other room. This could be a channel from my radio to a local DMR repeater, or an analog repeater for that matter. Or it could be a simplex frequency that could be used for many users in a local geographic area to communicate with one another. So with DMR, there's a couple more things that you have to consider when you program your radio. The first is, which is actually nice, you can name the channel based upon what you would like to call it, and you assign it to a number in the memory. My radio, I think, has 4,000 channels that you can store. The second thing that you have to program is something called a DMR radio ID. This is an identifier that's given to each operator on the network. I won't go into that right now, but just you have to, for now, just know that you have to associate your DMR ID with your channel. You also have to have the frequency transmission and receive pair. Now obviously for simplex those would be the same numbers, but for repeater, DMR works like an analog in that you have an offset that you have to kind of program in. The last two areas, these will be new to users who have not used DMR before, and that's the color code and time slot, as well as a talk group. So a color code is a number that essentially allows you to separate different channels out, on the DMR side. And the time slot, if you recall from the first video, with DMR there's two time slots for a given bandwidth. So for a given 1200 kilohertz RF channel, there's two time slots. So you have to use the right time slot that you're expecting to use, for example. So repeaters do have conventions in terms of what time slots they want you to use. We'll go into that in a little bit more detail. But the important thing for now is that when you're programming your radio, for analog, you would generally have to worry about the frequency pair, whether there's a CS, CT, CSS tone or PL tone, and maybe power, right, and offset. There's a couple more things you have to think about. And then talk groups, which we'll go into in a little bit, but you can think of these as different kind of rooms that allow conversations to happen. So as I said, a channel must be in a zone in order for it to be used by your radio. And you can do this assignment through the programming software or the front panel. Okay, we've kind of covered zones in kind of a high level detail. We've covered a communications channel. And next what we want to do is talk about a talk group. So a talk group is just a number that allows grouping of radio traffic into a single digital contact. So say, for example, one of the talk groups that exists is talk group 3124. And that's the talk group that's associated with Maryland statewide. You can think of a talk group as kind of a room where someone would want to gather to talk, like a watering hole or around the water cooler, right? So if I want to communicate with other users, around Maryland, I can connect into talk group 3124. And that is a meeting place, right, for those in Maryland. And it turns out that each state actually has its own statewide talk group. In addition to that, for the state talk groups, if I'm in the 3124 talk group, I'm having my conversation, say, with others across the state of Maryland. There may be another conversation going on from the Virginia statewide. Well, that's in a separate talk group. So all the communications for Maryland statewide, sorry about that. All the communications for Maryland statewide will be within the 3124 kind of room, and then there'll be a separate room for others having different conversations. So how does one kind of lay out, or how does one pick what talk groups you want to communicate with or just monitor? Well, there's a couple different ways that they will kind of break these communications down. The first is geographic. So for a given local area, one convention is talk group number 9 is reserved for the local repeater traffic. So if you want to just have your broadcast go to the local repeater itself, you would communicate with talk group 9. You could also have a talk group that goes to state. So I've talked about Maryland 3124, Maryland statewide. There's also national talk groups. So this could be for the entire United States or entire country overseas, as well as worldwide talk groups. So talk group 91 is the worldwide talk group, and on any given day, that talk group is used quite a bit. So you can kind of log into that and listen, and you can hear lots of people talking. Other ways of kind of organizing communications is by topic. So this could be certain technologies that you're interested in, or a certain topic. Languages, I'm sorry, maybe English or Spanish or Russian. There's different talk groups by language. And then finally, organizations. So Jamboree on the Air, there's several different talk groups for that. And this weekend is the Jamboree on the Air event. So there'll be communications with Jamboree on the Air. There's talk groups for veterans, for example, that you could join into and have common areas of common concern. And as well as radio clubs. So K3 BWA, for example, we have our own talk group now. I think it's 3203111. So that talk group is associated with our particular club, and we can make calls between members in that talk group. All right, so we've talked about we started at the highest level where there was a zone, right? You think of those little bubbles as how I'm grouping the channels that I want to talk with. I have individual channels where I have to set the RF parameters as well as the time slot information, talk group information, color code information. And then one concept I said I would talk about in a little bit is this thing called the radio ID. So with DMR, you have right? As a radio operator, we are licensed by the FCC, and we each have a call sign. Mine is Kilo 3 Juliet Sierra Juliet. With DMR, you actually have to get a different identifier type called a DMR ID. And it's required to have one of these in order to communicate on the network. You can think of the DMR ID as an address that you'll use to kind of call someone else, or in the case of data messaging, to kind of text someone else. You obtain this ID from a website, radioid.net. And when you register to get your DMR ID, you have to prove that you are the valid license holder of that call sign, and there's a process that they use to kind of validate you. It doesn't take but maybe a couple of days to get that complete. Once you have that process completed, they will assign you a radio ID. So what you'll see on the screen there, what you'll see on the screen there is the radio ID for my call sign, 318-3736. So that's the DMR ID for myself. And you can see my call sign name, location, and country. So one thing with operating on DMR that you have to keep in mind and abide by is the radio ID is not identified in the actual channel itself. So if you would look at the raw bit stream, the DMR ID is in the bit stream, but your call sign is not. Now, some of the amateur radio types of DMR, the system fusion that I mentioned before, they do include that. But to keep good with the the regulations, when you're making radio transmissions on DMR, you need to identify yourself with your call sign, and this is just like you would do with an analog repeater conversation. You have to identify yourself every 10 minutes, for example. Okay, so I spent quite a bit of time going over some key definitions associated with DMR. And what I want to do at this point, I'm going to kind of end this video, and in the next segment of the video, I'm going to go into some examples of the programming software that I have and show all these concepts and go into a little bit more detail to help hopefully tie these things together. So thank you very much for watching this video, and if you have any questions, please feel free to reach out to me. My contact information is on the first slide, and please tune in for the next video. Thank you very much.